So moving on to question 5 from the FP1 June 2016 paper. So this question is about parabolas, and for part A we're asked to show that the chord PQ has this equation presented here. So how do we begin with this question first? Well, we're going to need the gradient. So m here, how do we get that gradient? Well, I'm going to do my y2 minus y1 divided by x2 minus x1. So we're just using the gradient formula here when we have two coordinates. So that's going to be 2aq, that's aq, I know my writing's a bit scruffy, divided by minus 2ap. Now we divide, so it's going to be aq squared, this is my x2, aq squared minus ap squared. Now we just need to factorise, so we can factorise a 2a on the top, so it's going to be 2a times q minus p. And can we factorise the denominator? Well, we can factorise out an a to give q squared minus p squared in a bracket, which is difference of two squares. So that's going to be a times q minus p times q plus p. That's the difference of two squares. Q plus p there. And then we can just cancel down like this. So I can cancel a q minus p with a q minus p, and then we can cancel one of the a's with one of the a's here. So that's going to leave me with 2 divided by q plus p. So that's the gradient. Now all we need to do is sub this in using the y minus y1 is equal to m multiplied by x minus x1 formula. So if we do that, I'm going to sub in here the point P. So I'm going to put y, so subbing in this as my y coordinate for example, so it's going to be y minus 2ap is equal to m, so that's going to be 2 divided by q plus p. And then we're going to multiply this by x minus the x coordinate, so minus ap squared, so x minus ap squared. So what do we do next? Well, to manipulate this now, all we're going to do is we're going to multiply out here, so that's going to be 2 divided by q plus p times by x. This q and p doesn't go well with my English, and then we're going to times out the second part of the bracket as well. So what that's going to give is y minus 2ap, and that's going to be equal to 2 divided by q plus p x, and it's going to be minus 2 over p plus q, or q plus p, doesn't really matter. I should really keep it the same, very inconsistent, and ap squared. So now you just got to manipulate the algebra here to get it into this form. So it doesn't look quite like this at the minute. We've got this denominator of q plus p that's causing a few issues, but we're going to get it into this form. So the first step here now is to factor out 1 over q plus p. So that's going to give me y minus 2ap. That's equal, so it's 1 over q plus p. So it's going to be 2x minus 2ap squared. 2x minus 2ap squared. 2ap squared, like that. And now what we're going to do is we're going to times it through by q plus p. So what that's going to give me is this. So I'm going to get y minus 2ap. That's going to be equal to, and then it's just going to be this bracket. It's going to be equal to 2x minus 2ap squared. 2ap squared, like that. Oh, no. So there should be another bracket here. Oops, I missed that. So that's going to be the p plus q that we said we're going to times it by, our q plus p. So q plus p. So what you're going to do now is we're going to expand these two brackets using FOIL, and then we're going to add it, or manipulate in the correct form here. So what's that going to give? So it's going to be yq plus yp. I'm going to get positive yp. I'm going to get minus 2ap squared So 2AP squared minus 2APQ. That's going to be equal to 2x minus 2AP squared. This question is really long and it's really easy to make a mistake, so just take your time with it, guys. Minus 2AP squared. And then from here now, we can just cancel this 2AP squared here. So when we add it to this side, it's going to become 0. And then I can add the 2APQ onto this side. So what I'm going to get left with then, so if I take this up here, so I take it up there, what I'm then going to get left with is YP plus YQ. YP plus YQ. And that's going to be equal to 2x plus 2APQ. That's an x plus 2APQ. And then hopefully you can see that we're just going to factor out the y, and then we have it in this form. So y is equal to p, sorry, y times p plus q is equal to 2x plus 2apq. So that's part A done. A very long part, but thankfully the next few parts are quite quick. So let's move on to the next parts. So moving on with part B here, we have to show that PQ is equal to minus 1. And we're told that this chord here, passes through the focus of the parabola. So that's a big clue there, and it's only 1 mark, so hopefully it's clear it's going to be pretty quick. All we need to actually do is sub in a 0. So what we're subbing in here is just a 0. So how do we do that? Well, we're going to sub it into this here. This is the equation. So if y is 0, this left-hand side here is just going to be 0, right? That's going to be nothing. So what I'm going to get left with here now is 2 times x, which is a, so it's going to be 2a plus 2apq plus 2apq. And this is equal to 0 because the y is 0. And now we just need to keep solving this. So what I'm going to do is I can factor out the 2 here. So I can factor out the 2. I get a plus apq. This is equal to 0 still. We can divide by the 2. So I'm going to get a plus apq is equal to 0. And then here I'm going to subtract across here. So what I'm going to get now is apq is equal to minus a. And then if we divide through by the a, that's going to give me pq is equal to minus a divided by a, which is minus 1. So that's your 1 mark there for that. So for C, we have to use calculus to find the gradient of the tangent to the parabola at P. So it's 2 marks. There's a couple of ways you can actually do this. My favourite way of doing it is to differentiate implicitly. So implicit differentiation. So we do it down here, part C. So what we're differentiating here is y squared is equal to 4ax. So, and then we're going to sub in the point at P. So y squared is equal to 4ax. 4ax. So to differentiate implicitly, let's deal with this left hand side first. So because we're doing dy by dx and this is a y, what that's going to give me, it's going to be 2y. So it's as if you're differentiating it, but remember, because we're differentiating with respect to x, this has to be dy by dx. dy by dx. And then this side here, the right hand side, 4ax differentiated with respect to x is just going to be 4a, right? So now, to get dy by dx, we're going to divide through by 2y. So I'm going to cancel straight away. So dy by dx is going to be equal to 2a. Sorry, that's an x. So it's going to be 2a divided by y. And we know y at the point P is 2ap. So that's 2a divided by 2ap. So 2a cancels with the 2a here to just leave us with 1 over p. And that's your 2 marks for that one. And then finally for D, we should have enough room here. We have to show that the tangent to the parabola at P and the tangent to the parabola at Q are perpendicular. So we've just worked out the gradient here of the tangent to the parabola at P. So we've got to think about this at Q as well now. So for D, if we do it down here on this side, for D now, we need the gradient of the tangent at Q. So hopefully it's clear to see that it's going to be 1 over Q, because all we're doing is we'd be subbing 2AQ in here. So it'd just be the exact same formula, but I'd get left with 1 over Q. So Q is going to be 1 over Q. Like that, right? So now, what we know is that if we multiply these gradients together, the product here, so the multiplication, should give me -1. If they're -1, then it's perpendicular. If it's not -1, then they're not perpendicular, but we're showing that they are, so it should come to -1. So 1 over P times 1 over Q, that's going to be equal, that's a P, that's going to be equal to 1 over PQ. Well, we already established in part B here that PQ is equal to -1, so this is the same as 1 divided by -1, which is -1. So therefore, the perpendicular. And that's the full part for D, and that's the full question 5 done there.